Have you ever wondered how optical illusions work? How they trick our brains into seeing things that aren't there? Well, there's a neurological explanation for all these illusions. Optical illusions use shape, size, movement, and color to trick our brains into seeing things that might not be there. Today, we're going to explain some common optical illusions and the different ways they trick our brains.
We first have to understand how we perceive color. Newton observed that color is not in the objects, like the red is not in the apple. The surface of the apple is reflecting what we see as red. An object appears white when it reflects all the light wavelengths, but when the object absorbs all the light wavelengths, it appears black. Red is somewhere in between. The human eye turns light into color. Your lens, eyes, send light wavelengths back to your retinas, where rods, which are light receptor cells, convert the information into electrical signals and send them back to your thalamus, which is your sensory relay center, which then sends the information back to your visual cortex. This is the basics of how we perceive color.
We now know how we perceive color, so let's use that information to break down this optical illusion. This is called the disappearing dot illusion. There is a circle of purple dots with a black cross in the center. One dot disappears at a time and then returns as the next dot disappears. Stare at the black cross and notice the empty space. What do you see? As you stare at the black cross, the disappearing dot should be replaced by a green dot in your peripheral vision. This dot substitution is because your brain fills in the blank and takes the green dot for granted when it's not in the center of your focus. Your brain just assumes that it is there because green is the opposite of purple on the color wheel. This is called the Troxler effect. We now know how we perceive color, but how do we perceive shape and depth? Depth perception is through both monocular, one eye, and binocular, two eyes, cues. Monocular vision is not good at determining depth. When an image is seen by one retina, the relative size of one object and other objects are compared. In binocular vision, these relations are compared from both eyes, since each eye has a slightly different angle. With the information compiled from both eyes, we're able to see in depth. The relative size of objects are measured in relationship to each other. So if objects are closer, they appear larger, but if they're farther away, they appear smaller. It is just a matter of size comparison.
The hearing illusion is another well-known shape/size illusion. The hearing illusion consists of bike spokes radial pattern. A radial pattern is where a set of lines all lead to a common center, behind two identical parallel straight lines. When your brain sees the radial pattern, it focuses on the middle. When the radial pattern makes it look as if you are traveling towards the lines. Like in Star Wars, the stars turn into lines as the Millennium Falcon goes into hyperspeed, because it looks like you are moving towards them. The lines appear to be warped and bent, but they are actually two straight lines. This leads us to the question of how we perceive movement.
We perceive movement through monocular and binocular vision. Monocular is good at perceiving close-up motion, but is bad at perceiving motion that is far away. Binocular vision is better at viewing motion from a distance. There are two ways we perceive movement. Number one, our retinas track motion using light wavelengths. In order for this to work, the moving object has to be really close to the retina so the retinas can register it as movement. The second way we perceive movement is our retinas examine the position of the object, tracking its movement, and observe features such as size, light, color, and more.
The spinning snake illusion is a really famous example of how our brains can register false movement. In this illusion, the patterned circles will look like they're spinning. Saccades, or wandering eyes, have a big part in this illusion. If you focus on one point of the illusion, the snakes will stop rotating. Movement illusions like this are caused by the unconscious movements of your eyes. This is called a saccade. Like said previously, in order to stop the image from wobbling during the saccades, the brain stops our perception for a split second. At the same time, the brain loses its orientation. The loss of orientation is interpreted as movement. This is the basics of how most movement illusions work.
Now you know all about how optical illusions work. I hope you can use this information whenever you come across an optical illusion that seems impossible. We hope you enjoyed the video. Thank you for watching.